Welcome to homework.
So in this question, there are two parts, right? So in the first part, we have that if psi sub A and psi sub B are orthogonal, right? If they are orthogonal, right? So and we normalize them, both of them, right? So what would be the value of constant A in equation 5.10, right? And part B states that if psi sub A is equal to psi sub B, and they are normalized, so then what would be the value of A, right? So let's start with the solution. So for part A, let's start the solution. So first of all, what we need to do is to find out the value of A, that is a normalization constant, and the normalization constant A of a function is given by the equation psi plus minus r1 and r2, right? So that is equal to A psi sub A r1 unit vector psi B, right? Psi sub B r2, right? So plus minus, and now I'm running out of space over here, so I'm going to write the rest of the equation in the next line. So I have psi sub B r1 psi A r2, right? So now this is the equation, and what we need to do over here is that when we will normalize a function, so the following equation, the equation I'm going to write, it must be valid, right? That is 1 is equal to integral psi star integral d cube r1 d cube r2, right? So now we have the equation for the psi function, right? The wave function. So what we are going to do is that we are going to plug it in, right? And since a is a constant, so we would be writing it outside the integral sign, right? So yeah, integral psi sub a, right? um, r1. I'm writing this equation from the above equation that I just wrote, right? So then I have psi b 2, right, plus minus psi b r1 psi sub a r2, right? So now over here, this psi star, right? So this is equal to this equation, this above equation, fine. And next we have simple psi, right? So let's write its equation. So that would be, now I'm still writing the same equation, right? So over here, since I have ran out of space over here, right, so I'm going to write the rest of the equation the next line. It is a very long equation, so I would be writing from here. So I have psi a r1 psi sub b r2, right? Plus minus psi b r1 psi a r2, right? So then I have d cube r1 d cube r2, right? So for the for this psi, we have written the same equation, right? Same this equation, but without the star sign, right? So now what is the next step is that since um we have one on the left hand side, right? We have one over here, we have one on the left side. So what we're going to do is that we are just going to shift this over here, and since it is being multiplied in the right hand side, so then we will shift it over here, so it would be um in the denominator, right? It would be divided. And after that I'm going to separate the variables, right? So I'm going to open up this square brackets, right? And I would be writing them separately because we have a plus minus sign in the middle of these terms, so we can write it separately. So let's take a look at that equation. So what we would get in that case, so we have on the left hand side we have 1 divided by a square, that is equal to integral, that is equal to integral psi sub a r1 square psi b, right, r2 square d cube r1 d cube r2, right? So the next term is since I have very little space over here, so I'm going to write the next term in the next line. So it is similar like right, I'm just writing this above equation, but I'm writing them separately, right? So I have psi sub a star r1 psi b, right, r1 psi b star r2 psi sub a r sub 2 d cube r1 d cube r2, right? So plus minus again, I'm going to write the next term in the next line. So I have um, psi b star. So star psi sub b, right? I'm writing the third term. Then we have r1, right? Then we have psi a, right? It's always that when you would open the parentheses, the terms written between written within the parentheses, right, that would be multiplied. So um, just be very careful, right, because there are many um, variables over here, and keep in mind about the star sign, right, because this equation is written once with a star sign and then again without a star sign, right? And every time everything between the square bracket and the other brackets, they are being multiplied, right? So just keep that in mind and be very very vigilant while writing these equations, because there is a lot of chance where you can make a mistake and you'd lose your marks, right? So um, we have star psi sub a star, right? Then we have r2, um, then again we have psi b r2, right, d cube r1 d cube r2. Last I'm going to write the last term. So over here we have psi sub b r1 square psi sub a r2 square d cube r1 d cube r2, right? So when you'll do the integration on both, on all four of these um, terms that that are present over here, right? So you would get that 1 over a square is equal to 1 plus minus 0 plus minus 0 plus minus 1, right? So this would be equal to 2, right? And when you will solve it for a, you will get that a is equal to 1 over under root 2, right? So this is the solution for part A. When the psi sub a and psi sub b are orthogonal, right? Next we are going to solve part B, in which we need to find out the value of a, right, when psi a is equal to psi sub b. So for that, let's start the solution, right? So when this is the case that has been given to us, so we have the equation and it is normalized, right? It is given in the question. So we have a 1 on the left hand side, and that is equal to a square. Similarly, the integral sign over here, we have 2 psi sub a r1 psi a r2, right? So star, then we have 2 psi sub a r1 psi a r2, right? So I'm going to write d cube r1 d cube r2 in the next line, right? Because I ran out of space over there. So now what you're going to do is that, as you can see over here, this 2 and this 2, when they will be multiplied, we would get 4, and that is a constant, so we can write it outside, right? And again we would shift this over here, so we would have 4, and that is equal to integral psi a r1 psi a r2 square d cube r1, sorry, it's d cube d cube r1 d cube r2, right? And when you do the integration, you will get that all of this, it tends to be equal to 1, right? So when we'll solve it for um 1, when we solve it for a, sorry, so we'll get that a is equal to 1 by 2. So this is the solution for